right.
Hello,
All
guys.
right.
Hey, Shiram. Good morning.
Hey, good
How are you
morning.
doing?
I'm good.
Awesome. Hello, guys. This is Chi. I'm the co-founder and the CEO of KITE AI. And here with me today are uh, Scott, my co-founder and CTO from KITE, and Professor Shiram, who is actually our very special guest and the first guest for the AI Unchained podcast series.
Glad
Cool.
to be here.
So yeah, awesome. And very excited to start our topic today with Shiram. And a very quick background intro about Kite and what we are doing today with Shiram is so Kite is the first purpose-built layer one for AI. At its core, we're trying to really, ensure the transparent attribution and fair incentive to the key AI contributors from the end-to-end workflow with our groundbreaking consensus mechanism proof of attributed intelligence that's serve underline. And today, what we are very excited about and trying to kick off is the Proof of AI Lab, which is a global research and media initiative advancing innovation at the intersection of AI and the blockchain. And in this lab, we will have multi-programmed global initiative include the Proof of AI Aliens, Proof of AI University, and Proof of AI Journals, and today, the AI Unchained podcast. So let's maybe start with a self-intro from Shiram, which is our first guest for this podcast.
Awesome. Thank you, Chi and Scott, for having me here. So, again, Shiram Vishwanath. I'm a professor at the University of Texas in Austin, Texas. To give you a brief bio on me, I did my PhD back in 2003 from Stanford in engineering, in a combination of engineering and statistics disciplines. And since then, I've been a professor now 21 years plus at the University of Texas. I've had the good fortune of working with a lot of smart people over the past 2 decades in the domains of blockchain, AI, coding, information theory, and various other related disciplines. I'm currently also a fellow of the IEEE. I'm a senior member of the National Institute of Inventors, National Association of Inventors, like a correction there. And I also am a tech fellow at MITRE. So it's a pleasure being here. I'm actually very happy to be part of the first of these series and look forward to seeing how we can discuss not just proof of AI in greater detail, but just think through all the implications and advantages of bringing Web3 and AI together in a unique manner.
Awesome. That's super cool. And actually, I cannot wait to asking you a lot of questions about your experience at the intersection, Sherman, how you see right now AI is going and why blockchain can serve as a critical piece for the future of development of AI. But before we kick off, maybe Scott and I can also give a very quick intro about ourselves. So Scott, do you want to actually take the mic?
Sure. Yeah. So I'm Scott, co-founder and CTO of KITE AI. I built, this is actually a second startup. I built a streaming DB company before this one. And before that, I was building foundational infrastructure, data infrastructure at Uber before. So I built Uber's first internal skill.ai. That's data infrastructure to support the AI, providing labeled data. The growth team from myself to 200 people. And before that, I was a founding engineer at Salesforce Einstein AI Cloud. This is early 2014. And then before that, I was a UI/UC graduate school. So yeah, I spent last 15 years building foundational data and AI infrastructure. Yeah, that's my background. Chi, do you want to go next?
Sure. And yeah, I'm again the co-founder and CEO of KITE. So I spent the last decade of my career in mainly AI and big data. So my journey start from my PhD time at UC Berkeley, focus on machine learning and causal inference. And after school, I joined a AI startup as a founding member to work on automated machine learning platform problems, which is about 7 years ago. And also the company quickly trained to one of the top three AutoML platforms in the industry at that time, which is quite interesting and fulfilling journey. But in the process, or I particularly recognize that the big challenge for AI adoption, which at the time mainly about actually predictive ML adoption in the industry, is the data piece. The data silo, data quality, and all the stuff become a huge pain point for industry, especially enterprise companies, to adopt ML/AI solutions in their organizations, especially when it's put the model into production ready environment. So that's where I recognized the importance of data and data infrastructure. Then I left the company and I joined at a company called Databricks. Right now, probably the largest data infrastructure or one of the largest data infrastructure companies in the world to lead product management for their data engineer solutions, especially about ETL pipelines and relevant stuff. So yeah, then after Databricks, I co-founded KITE AI with Scott, which right now is focusing on using the intersection of blockchain and AI technology to really help bring the attribution and payments for AI assets, especially nowadays in the with the interface of AI agents that's what pretty much like being interacting with all the underlying AI resources and assets. Yeah. So that's my background.
Awesome. Let's go to the main discussion topic today. We prepare a list of topic, but I think we can go, a little bit free form. If there is a particular interesting point, we can drill deeper. Let's do that. I can kick off with the first question. Shiram, your work actually bridge information theory, coding theory, and also blockchain and AI. Can you actually give us a layman's explanation how these field interact with each other?
Awesome. Yes. So yes, I did my PhD in a domain called information theory. Some might be familiar with the fields, but I can tell you a little bit more. It measures information content in objects, in data. It differentiates between garbage and actual information. If you have used tools like PDF, have used any type of zip or other tools, those are based on information theory. So is the type of error correction as well as storage systems that you might have used both on your computer and on your phone and other devices. So that was my code background back 2003 when I first started. But then it turns out information theory, think of information theory as like a foundation from which you have a launch into various other subjects. And one natural subject is AI, because, and indeed, many people who did information theory back in the day now do AI, many of them famous. So the whole idea behind the synergy between AI and information theory is that ultimately to do AI, you need to learn representations. You need to find things like latent spaces. You need to really think through how best do you represent this data. And that representation part is effectively at its core extraction of information. Also, to do generative AI, you need to think through how best to be able to take processed information and generate new things out of it. And again, that generation process can be viewed very much as a process coming out of information extraction, information processing, etc. So that's the relationship between information theory and AI, and it turns out there's actually a deep relationship between information theory and blockchains. And this is something that coincidentally was discovered by a bunch of information theorists, not just me. Folks like David Say or Shiram also discovered this connection, which is that essentially when you do blockchain protocols, the process of designing the protocol, the process of thinking through security, thinking through resilience of the protocol, thinking through incentives on top of the protocol often tend to become problems in information. So you can think of information theory like um, physics or like a science subject, right? And then you're able to use that in various very cool things. And it so happens that AI and blockchain are two cool things that come out of it, just incidentally. And so we almost stumbled into it and then realized, hey, not just do AI and blockchain come out of it, but there's synergy between AI and blockchain as well. And so that was a more recent exercise where we realized the synergy, and then one thing led to another, and now we're getting to realize that not only is the synergy significant, but the synergy is very impactful from a business or a overall market opportunity perspective. So the technical sides align well, and in the near future, I believe the business opportunity is massive.
I can definitely see the relationship here, and also even in blockchain today, it's actually a Byzantine fault tolerance failure problem. It's basically a game theory. You cannot assume each participant. You cannot assume each participant is going to act rationally or acting good feel. In this, you have to use the incentive to align them to in this case. Similar thing with multi-agent environment in this case. I think we are working towards more like in a multi-agent environment. If you have agent to agent communicate each other, what's actually information communicate between these two agents?
Yes.
It's actually a very interesting question we are thinking about recently.
Yes. Yes. So the multi-agent collaborative protocols, different types of or multi-agent communication protocols, are also very much inspired by a similar principle, which is what is the information being shared? How is the information being shared? How is that secured? And then how do you, for the minimal information shared, get the maximum impact? So think of it as what is the most compressed version of information I can share? So I do so quickly, scalably, while at the same time getting all these agents to give me the best output, which is again, interestingly, can be formulated as an information theory problem. So it's kind of interesting how what is essentially this foundational subject keeps popping up in different parts, because in the age of information, information characterization, information capture, information modeling is pretty important.
It is, and also I feel like in this case, it's probably a very new field here. But if you have multi-agent sharing information with each other, maybe have one agent trying to trick the other agent, if you're trying to manipulate the different contacts with each other, in this way, it may lead to very interesting result. And also, I feel like with the recently development from MCP protocol and this agent to service, agent to protocol, it's actually bring a more problem about how do I authorize the access? How do I make sure I discover the right MCP server? How do I make sure I'm not hacking to the MCP server or agent discovery?
Right.
In this case, you can easily there is no like a standard discovery currently.
Yeah.
It's like it's very easy, has bring tons of security issue as well.
Yes, agreed. So right now it's the wild, wild west. We're just in the process of formulating our core concepts as to the protocol design. There is not just a big risk, but a big opportunity to that risk. As we did back in the day, this is now a long time ago when we did ARPANET and these early protocol designs for the internet, there is a similar massive opportunity and a similar massive risk in terms of security, in terms of reliability, in terms of scalability, all of which we can solve over the next year or two. So I'm actually pretty excited about the fact that it almost feels like the early days of the internet again, because now it's agentic protocol design, which is very, very cool.
I agree. I feel like this is actually even bigger than early days of internet.
True.
Yeah,
I agree.
so
I agree.
arguably it's bigger. I feel like internet is put everything online in this case. In this case, and then you have first you have catalog online, then you have your mom and pop store online in this case. But AI feel like automate all the major things for you in this case. So that's why I think what kept me really pumped is that if you look at the revenue for AI in 2023, it's only $6 billion revenue, like the whole industry, AI industry, you know. But I think people forecasting in 15 years, by the end of 2040, this will grow to 6 trillion revenue, 6 trillion a year's revenue. That's actually a 1,000x. That's probably the biggest alpha, the biggest the trend over the next 15 years.
Agreed. Agreed. No, I think I not just heavily agree with this prediction of the trend, but I think the impact that people have usually seen on the street today is mostly text. They've seen what I call LLMs impact their lives in a huge way already. But I believe eventually in the next decade, you're going to see everything impacted, not just text, but you're going to see every type of media, every type of visualization, every type of rendering, every type of object be impacted, and every type of data that is being collected with respect to that object be impacted.
I agree.
Yeah, and by the way, I think this is already happening. From
Yeah,
that,
yes, agreed.
yeah,
Agreed.
I think one thing that I really like what a friend of mine was. We were just talking about how data right now is becoming the bottleneck of the like a development of AI models and everything. And then I was like, oh, there's a data scarcity or like a lack of data problem. And then my friend was like, is that really about the lack of data right now, or there's a lack of way to collect all type of data at the moment that is generating every second, every millisecond in the world? That's just different type, different variety that can be used for, like a multimodal use cases that in the future. But yeah, but I definitely felt like right now it's already happening with all the type of data that now we can capture and have like a way to interact and build models for that is impacting pretty much every single piece of our life. So yeah.
Agreed. Agreed. And you make a very, very good point, which is data is not just essential in terms of the access to it, but also thinking through how much of it can impact what type of model that's being built. There's a both again an opportunity here to be able to be the resource that's able to connect the data with the associated desired model output, which I think KITE is doing a fantastic job at, but we'll get to that soon.
Yeah. So
Awesome.
and also I want to get more add more context here is that if you look at the release from yesterday, the Llama 4, if you notice the Llama 4 now provide a native multimodal model in this case. It's like all the previous console model is you separate. This is a large language model. This is a vision model. But now Llama 4 just combine them together, use a mixture of expert. I think this is actually a trending. Another trending is you probably be a guest speaker will invite later. Yuke is my classmate, and he also lead NVIDIA robotic lab. One information he shared with me is that all the existing data, they lack tons of data to train a robotic in NVIDIA. The reason is that currently the only way to collect data is through the actual robot, and then it's limited one robot per day in this case. They cannot use the previous physical, they cannot use the previous data, for example, from graphic. The reason is that all the graphic data, they don't have this physical parameter. For example, they don't know what's the mass of this object. They don't know what's the friction parameter for this object. They need actually this physical, this physical data, physical world actual data. So they cannot use the data producing a game engine in this case. So that's why they build ASAC, foundational, physical world simulation system. They can only use the data from there. But if they can only use the data from there, you basically cannot use any of the existing data. You have to reproduce the data. Then they just have like console robotic in labs, just trying to reproduce the work, but it's limited one robotic 24 hours a day. And then based on this real data, they generate more than 100x of the simulated data. Use the same, digital twins, and then so when they do the training, they actually combine these two data together to train, the end-to-end foundational model to do the robotic work.
Agreed. I think the physical data, which involves and systems data, where you have a unique setting, maybe robotics, maybe drones, maybe different types of physical realizations, maybe manufacturing plants. That type of data is not just unique in its feature set, but is also a unique opportunity for people to be able to build meaningful first digital twins and then eventually fully automated generative models for synthetic generation, where you're able to bring every aspect of reality into the virtual world. So that's a huge, huge opportunity as well.
Yeah, and Shiram, actually, that's reminded me of one of the things or an initiative recently you are doing, that is a intersection of the system mechanism and AI. That's also relevant to like the Unity engine type of use
Yes.
cases. And I remember you commented exactly the same thing, that said when you guys try to just use transformer without adding the physics information or like a domain knowledge into the model, that's pretty much a garbage in, garbage out type of
Yes.
scenario at the moment.
So let me comment on that. Thank you for that segue. So effectively, transformers are very good at sequential reasoning, and rightfully so. They solve a lot of challenges from an attention/context perspective. But please note that one architecture. It's not a panacea. It doesn't apply as a just plug and chug type solution for any type of data, especially for data that comes from physical environments, that comes from systems environments. That data is not just multimodal, but also has very, very unique characteristics. Take gaming engines, take any simulation of a complex system. These type of data sets require highly non-trivial enhancements. So you have to think past just self-attention. You have to think through how do you better represent that data set, and then how do you better reflect the underlying constraints that are physical. For example, text doesn't have physical constraints. Text has grammatical and other constraints that are generated through human language or natural language, while physical systems like a robot have physical constraints. Gaming engines have physical constraints. And so to think through how those are different is a very important process that's ongoing right now, that we are working through at various levels, not just in my lab, but across different research organizations. And I think that in the next maybe even 12 to 24 months is going to define a lot of what we do in terms of 3D, in terms of 3D motion, in terms of more general large-scale system design with AI.
That makes sense. Actually, then in that case, indeed, the next question we have in mind is, I'm not sure if I know that you have not, you didn't join the GTC this year physically, but
Unfortunately.
Yeah, but if there's I'm not sure if you watched any online video or
I
if
did.
there's,
I did.
yeah, any like like a takeaways you have from
Oh,
GTC as Scott and I both physically have been there. I know our one of the strong feeling is like Gen AI literally now, like we talked in the beginning, could help with almost any problem in every
mhm.
industry in the future. But yeah, I'm
Yeah.
wondering if
So
yeah, go ahead.
like an example is that hey, we have a problem design this the new chips. We have AI. Then
Yes.
Oh,
Absolutely.
we have,
Absolutely.
yeah. So we have a problem have this GPU AI factory.
or
Now we have
E-
AI to create
yeah,
different
Exactly.
things. Yeah.
Exactly.
or
No, no, no.
uh, uh,
I heavily agree. Sorry, Chi, I'm interrupting you because
yeah,
that was one of my
go
big
ahead.
takeaways too, which is if you think about it, NVIDIA is a core hardware innovation company. They have built extremely innovative hardware solutions. And what they've enabled is themselves innovating in the hardware they're developing. So let me explain what I mean by that. It's not just the chip design, it's how do you package these chiplets together? How do now they're doing all types of 3D structures in the packaging, and the thermal emissions from the chip, the way you actually structure the entire design, is itself being enabled by AI. So AI will build better AI hardware, which will build better AI hardware, which was one of my big takeaways as well. Sorry, go ahead, Chi.
Yeah, it's yeah. First of all, completely agree. And another thing that actually I also saw a company that has a booth is literally like showing how AI could how they could use AI to help AI hallucination. It's like even you have problem with AI, we have another AI to help you fix the AI problem.
Yep,
So
yep, yep, yep.
that's what's
Totally.
fantastic now, how the world is moving forward. Yeah.
Totally, totally. I think the to your point, how AI helps build better AI that has intermediaries such as hardware solutions, other software means, including hallucination reduction. The future is this trajectory because as we build and refine these systems, it's always an incremental process until there's a big jump, by which I mean we will keep making gains. And then at some point, there will be a significant, uh, let's call it a nonlinear improvement, potentially an exponential improvement, which will bring more and more of these tools together in very nonlinear ways. That's what we saw with the first transformer, with the first transformer-based representation and generation. I think that's going to happen. There's going to be over the next decade 2 or 3, maybe more of these nonlinear jumps. They'll make incremental jumps and then one big jump, and then some more incremental jumps and one big jump. And that's the next decade. So the next decade, I think, is going to be very, very important for all of AI and likely for all of humanity as well. Sorry, I was just agreeing with you
Yeah.
heavily that I saw that at GTC as well. The energy was extremely strong, and the ability to take this thinking and apply it to every humanity-related problem um, was also highlighted, and very reasonable, very smart arguments made as to how to solve those problems with AI.
Agree, agree. And actually, like y- yeah, actually, one thing I felt in the room by looking at so many books is, like you said, there are so many different fields that are covered by people trying to use like AI for, like audio generation or like video generation, especially audio generation now is like a very common like a tool that people are doing. So you
Hmm.
can see there's a bunch of like, oh sorry, a common space where AI become more mature, like 11 labs type of
Hmm.
companies are showing like a very strong progress and
Yep.
like a good performance. But on top of that, Stan, actually one interesting startup that I saw in GTC was they're using basically Gen AI to detect the like the mm, sound. It's like the physical sound that's in the room for detecting the object, like a drone or anything that is, like a flying.
I
For
see.
example, like we're making noises around the room, which makes, which for them, of course, it's used for safety, used for defense, and different,
Interesting.
type of things. So it's just again, the reason I mentioned that is there are just so many interesting areas people are trying to use
Oh
AI
yeah.
now to
Oh
to
yeah.
to to solve for a lot of different problems. And even like uh, uh, another thing that I learned from friends is climate, like a climate or like a environment protection use cases that people are trying to use Gen AI to detect. For example, like detect whether uh, have the hurricane scout, like the
Ah,
for hurricane, whether it's getting close to the coastline,
interesting.
and if it's getting close, then they will send in the drone to deploy some of the physical materials to break
Cool.
or like to stop
Yeah,
hurricane
yeah.
from
Very
getting
cool.
close to where people live. And that's all they're trying to use Gen AI to
Very
solve.
cool. Very
Yeah,
cool.
it's
Very
just a
cool.
lot of
Let me give you one
interesting
more
use cases.
example. So there's a colleague of mine at Georgia Tech, and he's built a company to use audio to detect a sick animal in a herd. Very interesting. Or in a chicken coop. So imagine most chicken coops have lots and lots of chickens. To you and me, they all sound the same, but to an AI agent, they each one sounds distinctive. And so without ever tagging the chickens, by just the sound they make as they move around, especially at night when they think nobody else is around, you can early detect things like bird flu. Isn't that cool? That's a very, very, again, the audio example you gave made me start thinking of, oh my God, there's so many audio, just audio related applications that matter so much to everything that we do socioeconomically. Um, Especially in this case, early detection of disease among birds and animals.
Yeah, so
That's so cool.
this reminds me another startup my friend is building. So this they actually use the AI vision model to detect to recognize a kite and then this call a kite big animal, and then this he started with kite. The reason is that before this the only way you can do is that put a label in the kite
Hmm.
ear. That's
Hmm.
actually sometimes it causes some infection. It lost track
Yes.
of labeling. You couldn't find it. Now they just has a camera
Yes.
monitoring and then automatically recognize the cattle because each
Yeah.
cattle facial is actually different. You use
Yes, exactly. It's just we can't tell them apart, but they are actually different. They can tell each other apart clearly. And so I think the amount of opportunity, whether it be environmental, whether it be health, whether it be eventually, of course, things in space and further out into the galaxy, there is immense opportunity there. Couldn't agree more.
Yeah, it's just how amazing. Again, people have been talking about how to use AI for healthcare, for example, for a long time. But it's just eye-opening that now, besides those common hot intersection fields that people are, applying AI for a long time before even AI with computer vision and some traditional solutions. Besides that, every single other industries are adopting that. That's what's to me like the most fascinating parts. Yeah.
Agreed.
But, yeah. So maybe then let's move to the next topic. Actually, that is where we want to chat a little bit more about how your view on also attribution and rewarding
Yeah.
contribution piece. So at KITE, you know that we always focus on transparent attribution, rewarding contributions in this AI
Yeah.
economy. And attribution actually is one always one of the hardest topics in data and AI, especially when it comes to data attribution. Everybody will start throwing tons of questions about that. So what is your opinion about it? And do you feel like that's of course I think you will think it's important, but you felt like, yeah, in general, how do you view that, and how do you think like that's
Yeah,
should be solved? Yeah.
agreed. So I, first of all, as you correctly commented, heavily agree that attribution is very important in any type of IP, but definitely in AI. The way you want to be able to understand who contributed both on the data side and on the model side in a combination, ultimately, um, makes a significant difference in the value transfer in AI. So let's go into what I mean by that. Yes, AI is going to transform the world, transform the universe, the way we interact with the universe. But even more, what is important is understanding how value is created, managed, transferred, and ultimately attributed in AI. Because if you are not able to capture that value accurately, you end up in a situation very similar to what ended up happening with traditional software systems, where open source was relegated to a particular domain and then everything else became proprietary. There is a risk of that happening in a manner that essentially centralizes and limits access to AI. So the opportunity of getting attribution right is the opportunity of getting value capture right, is the opportunity of getting the ability to do value transfer inside of AI more accurately. And I think, um, did we lose Chi?
I think
No worries. I
yeah, she
can,
will
I can,
recover. So yeah.
no worries. I'll just continue. I think there is a significant, not just problem to be solved, but a significant opportunity in that problem when you capture attribution correctly, you capture value transfer correctly, and therefore ultimately enable a new AI economy.
I completely agree. I think one of the biggest trends, and people is worrying about this, is that with the new Gen AI, it's not like when you search Google, you have tons of this long tail website in this case, even though people never go to the second page. But because what you search differently, you still scan through each of the page and then give a reward for those people, because whenever
Yeah,
you visit them, you actually give them boost, and then the boost they can turn that attention into monetization in this case.
yes,
But in the world of Gen AI, everyone go to Perplexity. You ask your agent answer a question for you. In this case, you actually don't, this will be very unbalanced incentive. It's
yeah,
without attribution, it's almost impossible to reward whoever contribute data. Actually, this is already happening. Like I think a research shared,
Scott.
yeah.
It's actually worse. Without attribution, you can reward the wrong person, which creates all types of misincentives. So attribution is not just important for getting the incentives right. It is important for making sure you don't create bad incentives that ultimately cause the entire system to be controlled in a manner that is not good for the overall scalability or performance or overall value created by AI. So bad attribution can actually be dangerous. So attribution done in a principled manner is very important. Sorry, I interrupted you, but I just wanted to emphasize your point, which is attribution is critical.
So in this case, could you actually give one example? This is actually very interesting. This is a point I just heard. Could you give like one example why wrong attribution or bad actor, trying to manipulate attribution can be very harmful to the system, and how
Yes,
they can manipulate a bad attribution as well? In this case, I wonder.
yes. So that's where these type of what are called um, fault tolerant systems, both to Byzantine and to rational adversaries, is very important. That is where we started with protocols designed first of all with Bitcoin, but many others to provide what is called economic security. So To give you an example, if somebody could steal, manipulate, or ultimately misalign incentives, then that person enriches themselves and is actually parasitic to the system, because what was contributed by somebody else is now assigned to a third party. Think of this as very similar to a bank run, a stealing value created by somebody else in an economic system of any type. And that is not just a big negative, it's a drain on the system, but causes a trust issue. People don't trust the system as well. That has an overall negative spiraling impact. And the trust issue further causes the entire system to collapse. To retain trust in the system, to be able to work in a way where users can trust the system without trusting individual parties, which is called trustless or distributed zero trust systems, whatever you want to call them, is a very important feature, because that feature causes people to actively interact with the system, which creates value, and that value is captured and correctly attributed. So think of a misalignment as having a spiraling negative impact that causes things to go worse and worse and worse with time, or stagnate with time, while a correctly attributed system, a smartly designed system, as KITE is building, can lead to a very good positive reinforcement, which ultimately causes the system to create more value, resulting in more interaction, which again results in more value, and so on.
Yeah, that's actually quite interesting that you brought up, because initially when we were thinking about, like actually when you Sean, when you describe my first thought was like, oh, how could there's be a bad attribution, but then, or like a wrong attribution, but then that I realized that is exactly why we are doing KITE, because you don't want to your data contribution, for example, that
Yeah.
you created such a great like language comments, then people use that to train LLM, and someone else just like copy that because it's so easy to copy, and
It's
then
easy
put
to
that put that into like the system, and claim that, oh, I contributed to this data sets, and so I should get rewards.
Right.
But yeah, that's is exactly why we are building this like fundamental layer of attribution for preventing that.
And that's why I'm excited about it. I want to share my, not just, I think excitement is a milder word. I want to share my heavy interest in this, because it is a important problem that, if given KITE solution, will lead to much better decentralized attributable systems that cause incentives to be well designed among those participating, and therefore will cause the entire system to grow with time. So that's I think critically important for the ecosystem.
And also, without right attribution, then maybe we have someone impersonate another one. You may have data poison attack as well in this case.
Yeah.
And then
that's the thing. It's not just that people can steal value, but they can actually ruin the value created by poisoning, by attacking, by being in a completely irrational manner. And that's significantly more dangerous than just stealing value. Stealing value is dangerous, period. It's parasitic. But now poisoning is more than parasitic. It actually can destroy the value created.
And actually, just like what Scott mentioned, that right now, instead of going to any website or like search on Google, you just go to Perplexity or like ChatGPT to ask for questions, and then they'll give you the final organized or summarized answer, which, by the way, it's beneficial to the user. But on the other side, then what is the solution, or what is the underlying data sources or like services and like product providers that AI browser or in the future Gen AI is using is causing another layer of complexity here because the attribution now is not static anymore. It's not like, oh, I go to Google, I look for something, and then if I'm interested in this website through this, like a very short summary about the website, what they're doing, then I go inside. So it's very static. But when you start using Gen AI or like using agent in the future to do all the work for you, you don't know which service they will call underlying because they will
Yeah.
intelligently rationale with
Yeah.
the models, and then they will figure out
Yeah.
the best route and the best vendors. For example, like, oh, I will choose the
Yeah.
cheapest, but the same level of quality type of providers. Like GPU infra providers or other things, then that attribution even become dynamic
Yeah.
in the
Yeah.
future.
Yeah. Absolutely. You're very right in that. It is not just dynamic, and it has to be done in a principled manner because it's dynamic. But it is a more and more non-trivial problem given the complexity and given billions of agents all interacting with each other. Uh, Doing this in a scalable, interactive, and um, dynamic manner is very important. Agreed.
Yeah, cool. So then maybe the next question I have besides the now we talked about attribution is what do you feel like in the future, especially now, as we talk about attribution, the one of the key implementation about attribution is in the decentralized AI world.
Mhm.
So then, when it comes to the decentralized AI world or
Mhm.
AI powered economy, what do you feel like the key challenges that we will have in optimizing the AI model communications and interactions, or like at the agent level? It's pretty much will be probably in the future all going to be at the agent level that we see the yeah
Agreed.
AI
Agreed.
interacting with each other. Yeah.
Agreed. So I think to a small extent we've talked about a few of those already. The efficiency with which you do this for it to be scalable. Um, just remember the reason we. Let me back up a minute. I have a philosophy of why certain things work well. They work well when things have four core characteristics that work very well. When they are decentralized and um, designed to be permissionless, which means that things can interact freely in a decentralized environment. When they're designed to be, in some ways, embarrassingly parallel, again, decentralized aspects where things are peer to peer can be designed to be parallel and not sequential. When they're designed to be composable, and when they're designed to have some kind of recursive nature to them, which means you can actually build a simple module and then recurse to scale it. I believe that agent to agent communication should ideally have all four of the features, but even if it has a subset of these features, can scale well. What do I mean? It has to be designed in a decentralized manner that has permissionlessness to it, by which I mean if everything is permissioned in 20 different ways or hundreds of different ways, it makes it much harder to build something that scales and works well. It has to be designed to be embarrassingly parallel. And that's a technical term. What I mean by that is it has to be designed in a way where you can do many of these simultaneously in atomic manner without all types of dependencies. Number three would be it has to be composable. So whatever you do across different modalities, across different types, has to be designed in such a way that the entire system is composable. So I think, and hopefully there is some core modular recursion that we can build to scale these systems to the billions. But these characteristics will have to hold. The good news is that we built systems like this back in the day when we did TCP/IP, when we did a lot of things, and I'm old enough to have tracked that. We did things very much with this in mind: distributed, composable, parallel. Those same principles have to come about now, and they have to come about with more complexity to what you said, because earlier what we were doing was just sending bits from A to B, and bits from A to B, yes, you have to come up with some good principles, but that's an easier task than now having a much more sophisticated system that is dealing with billions and hundreds of billions of these, all working in with different architectures, with different mindsets, but a common platform to be able to do so. So A, very exciting direction, but B, it's not as trivial. You can't just take what we did somewhere else and graft it. It's not as simple as that. So I think the opportunity for research in the space is massive.
I agree. I feel like this is actually very similar to a TCP/IP protocol. How do you actually sharing the same results in a multi-tenant environment? Like you have this. I remember this BGP hot potato.
Yeah.
You know,
Yes.
on
Yep.
the internet service provider level, but you also have the share bandwidth. Trying to get more bandwidth, but back off. But this all depends on you actually good player. But some of them also design not only on the incentive level, but just trying to figure out what's a bad player. I think one of the recent, well, not recent, but for last 20 years, 15 years, 20 years, is Scott Schenker, from Berkeley, designed a software-defined network. In this case, in this multi-party different incentive environment. Maybe something we can learn from it as well.
Oh, absolutely. Yes, there've been some very smart people at the intersection of reinforcement learning controls, um, as well as networking, who've designed some extremely innovative solutions, some of which, by the way, have worked great in certain environments, multi-robot coordination, multi-drone coordination. I think some of those principles can very much be taken and applied here. Agreed.
I think once we have this multi-party collaboration, this presenting fault tolerance, if you have potentially assume some bad player, the algorithm design for this actually much more complex in this case, and then it's really hard to. So that's why most likely it's like more like a agreement or rules. We define simple rules, and then we observe how agent behave under these rules, and then improve based on this. It's like how you really define rules for real world in this case.
Also agreed. I think, to your point, initially we'll be defining a rules-based engine, eventually a domain-specific language for this, where we have the mechanism for us, similar to what we did in the early days of the internet, and then be able to build every type of, security policy, um, overall compliance and policy management suites on top of this. So I heavily agree that there's a big opportunity there.
And Shiram, actually, I have a question about what you just say that the future of agent system need to be very composable. And you also mentioned the recursion of
Yes.
the, like how to make it better. Could you elaborate a little bit more? Like
Yes.
how? Yeah, go ahead.
So if you think about it, and I'm sorry, I'm going to take a philosophical streak here before I get to something concrete. If you think about AI and crypto or blockchain systems have two very important common characteristics. They're both designed to be parallelized and both designed to be composable. And that was part of their success. AI, if we didn't come up with the initial neuron with the ReLU, ELU, GELU activation that ultimately could be tiled up into what's effectively a set of composable functions and run in an embarrassingly parallel way, we would not have AI today. If we weren't building peer-to-peer, libp2p, or otherwise architected parallel systems with composable functions between different types of value transfer, we would not have crypto today. And so both AI and crypto share at the heart composability and embarrassingly parallelness, and in some ways, because of the parallelness, a decentralized architecture on one is centralized, but a GPU-based, heavily parallel compute on the other. These two are just characteristics, but that's what made them go viral. That's what made them go completely out of control, other than the fact that initially things on both domains were permissionless also. So what do I mean by composability? I mean that ultimately different models can be submodels to other models. This is similar in spirit to what, for example, DeepSeek did in their model generation. But I believe the sort of models being submodels or sub-submodels and contributing to an overall, I call them daisy braids, but essentially a graph of models or a DAG of models, a directly cyclic graph of models, is going to be architecturally very important. What do I mean by that? I mean that models don't live on their own. They are part of a collection that is truly collaborative, where one model can actually compose with another model, can compose with another model in a manner that ultimately leads to a much more decentralized, distributed chain of models in a way that creates an overall performing model that's better than the sum of the parts. So each individual model is, if it's X, then you don't get X plus X plus X, but you get something much more because you've composed them together.
That makes sense, and that is where actually Scott shared just like a Llama 4, for example, they're
Yes.
have this natural mix of experts
Exactly.
MOE architecture that's carrying all the models together.
Exactly.
Go ahead, Scott. Do you want to say
No,
something?
that's yeah, I'm
Oh
done.
yeah, I think before if you think about before, Llama is almost the only major model builder don't actually have this mixture expert. It makes sense. It's actually much lower the cost. If it's the same parameter, the same parameter model is going to achieve better performance with mixture expert. It makes sense from cost perspective and then collaborating perspective. And I think later on, I agree with you, Professor. I think later on maybe have this some model, loosely collaborate with each other or closely collaborate with each other. In this case, attribution is that probably in this case is also very important in this case because you want to understand attribution and collaboration between these models as well. It's probably a little bit beyond data in that particular case.
Yes. To your point, the attribution is very important, and you have to get it working across these, not just, I think mixture of experts is one aspect of it, but this chain of models that is being dynamically ragged and dynamically fine-tuned. So I think this attribution is important every step of the way, but it's particularly important as you build these composable set of models over time.
I like the mention for the dynamic tune and dynamic fine tune in this case, because if we have a channel model, you can actually improve each individual component without affecting each part.
Exactly.
It's like a monolith service to a macro service where you can involve the system. This is also, think about the philosophy for AWS to break down a huge software decentralized to smaller pieces, no single point failure involved independently. I guess that's probably one of the benefits.
Exactly your point. That modularity and the ability to compose it in that fashion across modules in a way where you have redundancy built in and reliability built into the system is going to be the attribution of every scalable system, right? It happens in AI, we do it in blockchains, obviously, reliability is core part of it, fault tolerance. But that's going to fundamentally impact how we build these model architectures with time.
Yeah, really want to comment more, but we are now running out of time. So I just want to make sure that we're getting there. So maybe one last question here, Shiram, as you are working on the at this intersection right now for many years. Actually, I think over pretty much like decades. You're literally working on the fundamental technology for AI and blockchain. So where do you feel like if you have to just say one biggest intersection and breakthrough that can use AI and blockchain do things together in the next 5 years? Honestly speaking, it's a long year because as we know, like in AI right now, not even I think AI is evolving, to be honest, now even faster than blockchain. Like every month you got
Yeah,
something new, and
yeah,
it's so
agree.
hard to predict the next five
Yeah,
years. But maybe you can try, or like at least in the next
I,
2-3 years, where do you see the
I
yeah?
don't want to comment individually in AI blockchain, but I
Mm,
want to comment on value transfer.
mm.
We have to get value transfer done in a manner that'll add fuel to the fire. There's a raging fire, don't get me wrong, and the fire is creating amazing things on a monthly basis, to your point. But value transfer is not something that is an incidental benefit. If value transfer in AI is done right, then it is a major benefit. It's going to, let's say, 5 years without the value transfer, 5 years with value transfer will be, in my view, drastically different because it'll incentivize. See, right now we have lots of people working in AI, but it incentivize more and more people to contribute in a way that brings their ideas, their knowledge to the domain much faster rather than contribute in ways that sometimes are intermittent and limited. So I think if and it's imperative, it's important for us to get the value transfer done right, and then watch as innovation accelerates faster than it has ever accelerated in the history of AI.
Actually, for this one, if Sean, you have 2 more minutes, I have a
Yeah, yeah.
follow-up question here, which probably is a hard question because I felt
Okay.
like right now, as we already seen how AI is really fundamentally changing how, or will fundamentally change how people will code and ship product out for, like for solving some real world problems. And in that case, when it comes to like value capture, value transfer, um why would not just have the market that's being willing to pay for the services that you provide, which in the future everyone can provide service and products because you don't need to know code to be able to develop a product. And then if you are building something real and useful, then the market will reward you with money, with revenue directly. So in that case, why
Let,
that is not, like in short term enough for,
so,
yeah.
so let me speak to that. So from building little applications on top of a existing AI capability suite, to an extent, you're right. Those applications can be built in natural language. Those applications can be built much more easily. The opportunity for getting value transfer right lies in all the capability to build that application. So what do I mean? See, we are going to build some really amazing suite of AI solutions in the next 5 years. that take very, very unusual data types that we have not even thought of at the moment. Like you said, right? Sound to do things that we don't normally do with sound. Different other types of measurements to do things that we don't even think those measurements can reflect. Those type of tooling require people to do something very non-trivial. It's not just to write a couple of lines of natural language code. That is people coming together in unique manners, solving problems that ultimately do not reflect a simple AI tooling set. There's some enhancement to it. They have to think through how do you denoise something very, very messy, or they have to think through how do you capture features from somewhere you may not think any features exist. That process needs to be incentivized. That process needs value transfer, because with that is where you'll get the big jumps. So you'll get the little applications and lots of good applications, don't get me wrong, lots of enterprise applications, lots of consumer applications coming out of people building simple applications. But the fundamental capability improvements will be through correct attribution. Because if you attribute correctly and somebody feels that what they're contributing is going to be reflected, they're going to get the right compensation for it, they're going to get the right glory for it, that impacts a lot of how very difficult problems are solved. And over the next decade, I'm expecting a lot of difficult problems to be solved. Problems that over maybe centuries, but at least for the past few decades, we have not solved, right? Because we just could not find a good solution because it's either NP hard or it's something else. I expect those type of problems to be addressed through value transfer.
Really like I really like this answer, because you reminded us like the biggest value about AI is probably not on replacing and enhancing the existing system and existing solution, which like Scott mentioned, that the future of AI, it's TAM, or market size, probably is going to be at 6 trillion, but maybe it's for the existing markets. But the point, or like the future biggest value of AI is really unlock a lot of problems that we never thought about that we can solve before without AI, which makes the market probably 60 trillion rather than 6.
Exactly. Let me take it even further. The innovation in let's say 4G or communication systems was not Angry Birds. It's a great app. Kudos to whoever built Angry Birds. It is the Apple App Store. If you build the Apple App Store, people will build the next generation app, right? Building the app is easy, but building the App Store and that ability to capture value is hard.
That's actually what we target for in this case. I think in this over the next few months, we'll release more details how we actually build the app store, empower each of the AI builder, agent builder can build on top of us. But that's actually exactly our vision in this case.
Awesome. All right. This is great. Thank you for your time.
Thank you so much, Shiram. This is very I really enjoy the conversation, and your a lot of candid thoughts about where we are. Yeah.
My pleasure. Thank you.
Let's call it a day today. Thank you so much, and
Take care.
enjoy the rest. Bye bye.
Bye bye.
Thanks.